Class. Today we're going to start talking about the MOSFET. We already talked about the junction field effect transistor, and one of the big advantages of the junction field effect is the high input resistance or high input impedance of the device. In the case of the MOSFET, we even got a much higher input impedance because the gate is completely isolated from the rest of the device. Now we're going to look at two different types. The first one is the enhancement MOSFET, and if we go look further, we're going to talk about the depletion MOSFET. Now the big difference between the enhancement and the depletion, in the case of the depletion MOSFET, there don't exist a channel between the drain and the source. If you look at figure A, you will find there is no channel between the drain and the source. The moment I apply a voltage to the gate, what do? I basically induce a channel. Alright, I'm going to show you nicely what's going to happen in the circuit. I'm going to show you nicely. There's the drain, there's the source, and there's the gate. And you'll notice there don't exist a channel between the drain and the source. I repeat, there don't exist a channel between my drain and my source. The moment, and this part here will basically act as a capacitor, will have the same influence. That oxide layer between the gate and the substrate basically is like my dielectric material. Now let's go to figure B. When I apply a positive voltage to the gate, on this side I will create positive charge, and that will basically induce electrons on that side. And due to the electrons on that side, it will basically induce a channel. And now due to the channel, we will get flow from my drain to my source like that. But there is no current flow here. I don't have any current flow from the gate to any one of those terminals. That means this thing is completely insulated, my gate. And I got a very, very high input impedance or input resistance. That is the N-channel, not the N-channel, that's the E-MOSFET. And it's also an N-channel, but it is my enhancement MOSFET. Alright, there is the symbols for the E-MOSFET. There they show us the N-channel. In the case of the N-channel, you'll find the arrow is basically showing inwards. In the case of the P-channel, the arrow is showing outwards. Alright. And you can notice there's basically open spaces there. That means it will also show you that is basically my enhancement MOSFET. That means there don't exist a channel. You will induce a channel by applying the correct voltage to the gate. The next one we're going to talk about is on page 398 in your books. If you look on page 398 in your books, there will find the depletion MOSFET or the D-MOSFET. Now I repeat, in this case, there exists a channel between my drain and my source. I repeat again, in the case of the depletion MOSFET, there exists a channel between my drain and my source. In this case, we're not going to induce a channel. Also, they show us the N channel and they show us the P channel. Also with the three terminals, the drain, the gate and the source. That is the basic structure of the depletion MOSFET. Let's go and have a look what's going to happen when we're going to apply voltages to the gate of the depletion MOSFET or the D MOSFET. In the first case, apply a negative voltage on the gate. You'll notice here I apply a negative voltage to the gate of that, positive voltage to the drain, reference to the source. And when I apply a negative voltage, I will have electrons on the outside, like a capacitor, and positive charge in my channel. I will have a current flow, but that will be a small current flow. You can see ID is quite small in that case. The moment I make it more positive, my gate, when I make my gate more positive, I will have positive charge on the outside, and I will have electrons in my channel, and that will increase my current flow, my drain current flow. That means by varying the voltage on the gate, I can vary the current flow between my drain and my source. That is the case of the D MOSFET. I repeat, in the case of the D MOSFET, there exists a channel between the drain and the source. Alright, here's the symbols for the D MOSFET. If you look at the symbols for the D MOSFET, you will notice in the case of the N channel, the arrows show inwards, and here we got a solid line. Not like the case of the E MOSFET where it was broken, because in the E MOSFET we must induce the channel. In the case of the D MOSFET, there exists a channel between the drain and the source. In the case of the P channel, you'll find the arrow show outwards. We can quickly go through the other MOSFETs. Here we're going to talk about power MOSFETs. Where do they use power MOSFETs? They use them in amplifiers. They work quite nice in amplifiers. That means those things can handle more current. And that is our power MOSFETs. They just give us the basic construction of this. The first one is the E MOSFET structure showing there. And then we go to LD MOSFET lateral channel structure. That's basically the construction of these MOSFETs. There's the V MOSFET. Why V? Because the gate got a V shape inside the material. And there we got the T MOSFET. Looks like a T in the structure, all right? And then they also give us the dual gate MOSFETs and the symbols for the dual gate MOSFETs. One for the D MOSFET and one for the E MOSFET. All right, I will quickly come to the classes and find out if there's any problems or anything you don't understand nicely, and we'll quickly talk about it.